My name's Jim Duey. Longtime Clojure programmer. I picked up Clojure about 6 months after Rich went public, and I can't believe it's almost 10 years now. But love Clojure. It's the best language ever, except one of the big things that bugged me was that it's on the JVM. And I was not a JVM programmer, didn't like the JVM, but because of Clojure, kind of had to be there. So I've always, from the very beginning, wanted a native Clojure, basically Clojure that compiled to native code. So I started, I don't know, 3 years ago, working on Toccata. And so it's my attempt to improve on Clojure. And that's what this talk's about. So if you're curious about some of the bigger picture of Toccata, I gave a talk here last year, the next great functional programming language, part 2. So you can go look at that in the archives. It's on YouTube, I guess, or wherever, and kind of get a bigger picture. It was mostly vaporware then, and John said, "Yeah, great, that's what we want." It's like, "Oh, okay." So this talk is showing a little bit more of the concrete aspects of Toccata. It has, I've done a lot of work in the past year, a lot of it undercover that doesn't really have any visible effect, but this is kind of an update of last year's talk. So, oh, and by the way, I am very informal with my talks. So if there are any questions, any part you don't understand or want to see more of, just shoot your hand up, and it won't disturb me whatsoever. So let's go. Here's some places you can get some more information about Toccata. I just, I guess a week ago, so the code I've been pushing to GitHub has been in a private repo because I was force pushing and I didn't want to worry about anybody getting messed up, and it was junk anyway. So a week ago, maybe a little bit over, I pushed the first commit to the top GitHub repo. And that is the official Toccata compiler. This first commit is basically how to compile the most simplest hello world you can possibly imagine. And then the successive commits will be building up the compiler from that kernel, adding a piece one at a time. And so you should be able to read those commits and get an idea of what it takes to build a compiler. It does not follow the historical commits. Those are just ugly. There were so many mistakes I made. I mean, you guys are programmers, you know. As you develop stuff, you explore, you find your solution, and it's just ugly. So these commits are not that. They hopefully are cleaner and more easy to read through it. The Twitter feed, the Twitter account is where I only tweet stuff about Toccata itself. And then today's code that I'll be coding is in this bottom repo that you can grab that if you want to kind of see where I'm going or want to look at it later. And I heard somebody, a very accomplished speaker once, say, never do a live coding talk. And I was like, absolutely, never do a live coding talk. And here I am. So we will see how this goes. First of all, Toccata has Clojure's good parts. I really do like Clojure. Rich got so many things. Actually, he didn't get a large number of things right because he was working with Lisp, which already has a bunch of good things right. But he got a few things very right, and the combination of those things are just like genius. So I really, really like Clojure. And then here are the good parts of Clojure. Rich added a little bit of syntax that eliminated a bunch of parentheses. And so syntax is like salt. You add a little bit to a dish and it tastes really good. You add a lot and it ruins it. And so S expressions are the one true syntax. And then Rich added a little bit to it and it's great. Immutable data structures by default. That is just huge the effect that that has on programming. So really a big win there. And then protocols, which are a way of specifying interfaces, and they're polymorphic interfaces, and they dispatch on the type of the first argument. And we'll see some examples of protocols, because I blatantly ported those protocols to Toccata. So what else? I don't know if you guys, if you're not in the Clojure community, you probably didn't see the kerfluffle this week or last week of a guy that gave a talk last year about going from Ruby to Clojure back to Ruby, and then there's all kinds of turmoil. One of the complaints about Clojure is that it's hard for beginners to pick up, and it frankly is. Part of that is the Java legacy, and there's some other reasons. But one of the things I want to do with Toccata is make it really easy for beginners to pick up and to do useful work quickly, and then build on that foundation to, with a smooth path toward mastery. A lot of that is going to have to come through a book that I intend to write, blogs, documentation stuff. But also the language structure itself can do things to help. Toccata right now compiles to C, and then I use LLVM to compile to native. You could also use GCC. This also provides the opportunity to target like Objective-C to do iOS apps, or JavaScript, or Python, or whatever else you want to target Toccata at. So very consciously, I haven't started working on any of those, but I want it to be targetable to a bunch of other places. And then it includes category theory. Category theory is just awesome. Except for beginners or even experienced programmers that aren't familiar with category theory or aren't really good at math, like I'm not, the verbiage and the material of learning category theory can be really off-putting. And so even though I want to include the concepts of category theory because they're really useful, I want to avoid the verbiage and the learning curve of having to read crazy textbooks that have weird symbols in them, and really target it to the working programmer. Okay, so this is a definition of a protocol. Most everything in the core of Toccata is built on protocols. And so there are interfaces that are specified, and then the data types in the core implement those interfaces. This particular protocol is what I would call the core protocol of Toccata. And if you're familiar with category theory or other functional programming, you can read the names of these functions. So def protocol is a keyword. Container is the name of this group of function interfaces that names the protocol. And then each expression, like flat map, is the name of a function that a data type has to implement in order to have the flat map functionality. And the same for extract, extend, and the rest. So if you look at these names of these functions, you'll see that they have the category theory concepts. Flat map is the monad type interface. Extract and extend are comonad. Wrap and apply are applicative. Map is your functor.
So are you saying that every container data has to be a monad and a comonad?
No. You do not have to fully implement the interface. You only implement the pieces that make sense. And right now, I've implemented just enough of the interfaces to basically have the compiler compile itself. So future work will be expanding the definitions of various interfaces, various protocols. So no, you do not have to. In fact, as you probably know, you can't fully specify everything. Okay, so that is the core protocol of Toccata. And of course, there are a bunch of others, but the thing to note about those is that they're all a form of function composition. We have, the basic function composition of it gets called this function, and then the result of that function gets passed to the second function. That's your simple monoidal function composition. But those other flat map and the rest, the whole category theory stuff, are really more sophisticated kinds of function composition. So if you think of the way data structures compose data, you can plug various pieces of data together into a data structure. Those protocol functions allow you to compose functions. Why this is important is if you think of your work as a programmer, somebody or you gives yourself a problem, and it's this massive, I want to take over the world or whatever. You can't write program to solve that problem in one shot. So you decompose your problem and into smaller ones. And then those are probably too big, so you decompose those, and you keep decomposing until you get to very simple problems that you can actually write code for. And then you compose those solutions to build back up your final solution to solve your big problem. Knowing category theory and the concepts of category theory, that will inform the way you decompose your problem, because you can say, oh, well, that's a monad. If I decompose this, I can build a little DSL and have it be a monad. And then it makes the composition of your tiny solutions into bigger solutions much cleaner. And so that's why I want category theory. That's why it's so awesome. And once you have these interfaces, then what I found interesting is that I can do any other kind of paradigm of programming that I want to by implementing select pieces of that protocol. And so those are just some examples. And so I'm really looking forward to getting enough of the compiler up and running so I can start working on some of these things and really put out some cool code. Okay, one more slide. Another big dig against Clojure, and again, I think in my opinion valid, is the tooling around it. You have Emacs and you have Cider, and people have done some great work in making that happen, but we really need better tooling. And so one of the things I want to do with Toccata is really build out a tool chain so that when you sit down to write code, you have a lot to help you get correct code. And you'll see at the very bottom is the debugger. That is probably the first, after the compiler, the debugger is probably the first piece of the tool chain that I'll write. But ideally, you should never have to use the debugger. The other pieces of the tool chain should enable you to write code that is correct, and so that you never have to drop down to the debugger. Now, that's the ideal case, and we all know what will really happen, but that's the intent. So, any questions before I jump into some code? Comments? Yeah.
Show us the modeler.
Good question. So I don't know much about modeling yet, but it's like SMT solvers and SAT solvers sound really cool. And I am so looking forward to I hope to be able to implement an SMT solver at some point just to learn. But I think that if you write your code and you put in, I can explain a little bit later how to do it, but you put in runtime assertions of like this symbol at this point has to be of this type, which is basically type information. And other types of things like sum types and whatever, then I think that I can write a tool that runs basically a local web interface. You point it to a Toccata source file, and it can go analyze the file and say, this type of data structure is used in these places. And here are places that you have a polymorphic dispatch that if you gave me a little bit more information, I can turn it into a direct, concrete dispatch and not have to do runtime. Here's where your data is flowing through your structure, through your program. that kind of stuff. And then possibly even answer questions like, this code is guaranteed to never throw an exception, or core dump, because I have no exceptions, is guaranteed to never core dump, because you've handled all the error conditions properly. That kind of stuff. So yeah, a lot of it is hand wavy. It's still vaporware. And a lot of it is just vague ideas that I think I can do, or that somebody smarter than me can come along and do. And so we'll see. That's part of the pleasure of designing your own language, is that you get to learn a bunch of stuff. So, alrighty, let's do some code. Good old Emacs. So first of all, we do a little hello world. And if any of you are Clojure programmers, this should look pretty normal. So to compile a Toccata source file, use Toccata, which is a program that's actually written in Toccata. It's self-hosting. And that will compile and produce an executable, which I can then run. So that's the basic Toccata compile chain. We can try. How's that? Okay. So that is your basic hello world. What I'm going to build is a very simple web application, web server. And most of my career, I've been an embedded programmer. So I like frameworks, you know. I'll sometimes use libraries. But most of the time, I want to roll it myself. I want to write it myself. So we're going to start with a basic raw TCP socket and build a web server up from that. Admittedly, with very little error handling and all kinds of other things that you would want in production. But we'll see. OK. I also have this file, which I'm going to be copying and pasting from a lot. So one of the things I wanted is, if you're a Clojure programmer, we have Clojars, which is our centralized package repository. Other languages have package repositories where you go and you download stuff. I did not want that. The people that run Clojars do an excellent job, but I don't want somebody to have to run a package repository. So you can make GitHub, or not GitHub, you can make any Git repo a package you can import directly from the repo. You could also import from any other FTP or HTTP, even local files, which I'll show you later. Any of those can be a source to get a Toccata module from and bring it into your program. And eventually, what I'd really like to do is pull from IPFS. I don't know if you guys are familiar with that, but it's a distributed file system, worldwide distributed file system. So have no servers anywhere. It's just peer-to-peer. OK. So I happen to know that in the, I'll go ahead and show you. Or not. Here is the TCP file. You'll see a lot of inline C. So you can drop inline C directly into your Toccata code. At the very bottom here is a function called listen. This will open a listening socket on a particular port. So let's use that. Oh, also in Toccata, whenever you import another module or another file, you have to give it a prefix, a namespace prefix. There is no implicit imports or anything. You always have to qualify the symbols that you import, because it's just painful otherwise. So, let's listen on a socket. And we're going to assign that to a symbol, so I have to do port 80, because we're doing a web server. OK, let's see what happens. So it returned nothing. Because it's less than 1024, the bind or the listen call failed. And so when it failed, the listen function here, the TCP listen, returns nothing. So in Toccata, there is no Boolean value that has true false, or no Boolean type that has true false. There's only maybe, which contains another value. And then nothing is a special maybe value that contains nothing. So there is no true false. There are no true false values. So in this case, the listen failed, and so it returned nothing. So there are, you want to combine, do Boolean algebra or whatever. So there are two special forms, or and. These are the only lazy forms in Toccata. Everything else is strict. But or and are lazy. And so or executes the expressions one at a time. And as long as an expression returns nothing, it will then go to the next one until it finds the first one that returns a maybe value that has something in it. So let's do this. And it could not listen on port 80. So let's give it a port number it can listen on. And it didn't print anything because this value doesn't print. It doesn't have a side effect of printing anything. It only returns the. So let's make it print something just real quick. And the compiler is dog slow. I've got to work on that. I am working on that. But in this case, it started listening on port 8080, returned a maybe value of that server socket. So the value coming out of the listen is a maybe value that contains a server socket value inside of it. So let's do something with that.
So before you go on, if you take that back to port 80 and it failed, would you then print out the nothing from the first branch?
Good question. Let's see. I think it will. Oh, because I wrapped the nothing in a maybe, it succeeded, and so it didn't go to the second one, but yeah. Okay, so you saw I implemented the, or you didn't see, but I've implemented the map function on the maybe values. So now I take the maybe value that comes out of listen and call map on it, and then give it a function to call with the value inside the server socket. So that's going to be our handle connections function. And it is going to get the server socket directly that has been unwrapped. And if the listen fails, then the map is going to be called with nothing. And so it's not going to call handle connections. It's going to just return nothing on, and it's going to drop down to the println. But if the listen succeeds, then the server socket is going to be passed to handle connections. And then it's going to print waiting. And then I'm going to add one more thing here before I forget. We want to just loop continuously, because this is a server socket, and so we're going to. Here in a second, I'll accept the connection, and then once it handles that connection, we want to loop around and get the next one. So this is just a self-recursive call, and through the magic of LLVM, there's tel call optimization. So this will just sit and loop infinitely, and everybody's happy. Okay, so let's do something. So I happen to know that the server socket implements the extract function. So a server socket, the semantics is that it's a container that you can extract values out of. And those values are connection sockets. So when it tries to extract a value out of the server socket and there's not a connection waiting, it's going to block until it gets a connection. And then, in this case, it's going to println that value and then go on. So that's, when I came up with this, I was like, that's pretty cool. So let's see if this works. Okay, so it's waiting for a connection. And whoops, wrong. Here we are. So we're going to just use netcat to connect to the local host on port 8080. And there it is. It got a maybe value because the extract could fail. The listen socket could have gone away or whatever, the server socket. And so that extract may fail, which is an error. Or if it blocks until a connection comes in. But when a connection comes in, it returns a maybe socket. Everybody clear on that? Does that make sense? So we can go back and give it a couple more connections. And you can see that each connection prints a different socket. So as a long-time low-level TCP programmer, when I got to this point, I was like, that is so freaking cool. I don't have to worry about closing sockets. I don't have to worry about anything. This is the whole TCP infrastructure for the web server. The way this works is, in the embedded C code on the TCP side, Toccata is reference counted for garbage collection. And so when it creates a socket, it creates a wrapper data structure that has a pointer to a function that will close that socket. And so when the reference count for these sockets hit 0, essentially the reference counting subsystem frees them, which automatically closes the socket. Given the immense pain I have suffered in the past, trying to figure out where my socket leaks were happening, this is freaking cool, let me just tell you. For those of you that have not experienced the pain, you're lucky, but just take my word for it. Okay, let's kill this. Yes. If you write embedded C, if you're like doing an FFI or something, but yes, it is available to users. So pretty much everything that I use to write the compiler is available to users. That's the other thing I really want. In Clojure, the reader, the analyzer, and the like is not really accessible. You have to, and they're working on it. You have to do a lot of work to get that stuff. In Toccata, the analyzer, the reader, that takes a raw text file and spits out AST is just a library that anybody can call at any time. And so hopefully people that want to write tooling for Toccata can just pull that library in, they get their ASTs, and everybody, they're moving on down the road. Okay, so let's write another function. I got to spell it right. So we're just going to map over that maybe value that comes from the extract and call it a function to handle the connection. And this is just a plain old TCP socket. So I happen to know that on a socket that it implements a write function. So I'm going to write to the socket. That string. And every time I go over to this right-hand pane and hit Toccata, to compile and run, internally I'm going, I hope this works. So let's see. Hey, it worked. So now when I connected to the socket, I get the howdy folks back. And you can do that to your heart's content. Okay. Questions? Alrighty. So that is your basic TCP IO stuff. Kind of. Okay, so we're building a web server. That means we have to deal with the HTTP protocol. So there happens to be a namespace I wrote that, so what I did, so I did a namespace that will parse URIs, and basically I sat down with the HTTP RFC and took all the eBNF fragments and translated each fragment to Toccata code, and that's what this file is. It is a grammar, a data structure that describes the grammar of an HTTP request. And it's just a data structure. And you can page through all of this stuff and see all kinds of, there's all kinds of things that HTTP has that I wasn't even aware of. So down at the very bottom here, and it's a little bit ugly because of the formatting, but this request message is the definition of the structure of a HTTP request message. And so that is what we're going to use to parse. Okay, but this data structure is just a data structure. It is not a parser. So I also brought in this namespace, which is a simple recursive descent parser. Pretty easy to write. Oh, and that grammar that for the HTTP stuff is essentially parser combinators. That is what it is to build up the grammar. But uses the free applicative, just for all you functional programming geeks, uses the free applicative to build the grammar. So, and then this recursive descent module takes that free applicative structure and generates a recursive descent parser out of it. And so that's the way you're going to handle parsing in Toccata. You build your grammar, and then you can do anything with that structure you want. You can spit out an eBNF form of it. You can spit out a GraphViz file. You can do whatever you want, because it's just a data structure. But one of the things you can do is to call this and get a recursive descent parser out of it. I also intend to write a string parser that will parallel all the options, process all the options of your grammar in parallel. But that's, simple recursive descent is good enough right now, so that's what we're going to do. Okay, let me go get the actual function call. So that is how you get your HTTP parser. So parse HTTP is a function that will take a source of input and parse an HTTP request out of it. That input source could be a file, or in this case, it's going to be a socket. So let's do that. Println parse HTTP and something, and then the socket. So the socket also, just like the server socket, it implements the extract protocol function. Every time you extract from a socket, you get a string, a buffer, and that's it. You know that you have to hold on to that buffer because it's going away. You can't extract it again from the. Every time you call the extract, you'll get a new buffer. So this cache call turns those sequence of extracts into a lazy linked list. So that lazy linked list or that structure implements the list interface, first and next, or head and tail, or cons and car and cooter. And that's what gets passed to the parse HTTP. So let's see if this works. Except to do our request when I use my Firefox, and you can see that it went off and Firefox hammered that socket to, it made a bunch of requests to try to get the information. But each request got parsed. You can see the method as get. The path was just foo. And so the path is a list of strings, each path segment. In this case, there's only one, and the HTTP version. So that it's parsing HTTP. Okay, so we need something to Emacs. You know, you do one wrong keystroke and you get all kinds of stuff. So we need something to send down the pipe. So I wrote an HTML, a very simple HTML templating namespace. So it defines, so this is how this def type is how you define data types in Toccata, and they're basically records. And in this case, the empty only has tags and attributes as part of its record structure. Generic HTML element also has elements. And then I implemented a protocol, or defined a protocol, and that makes an element. Did some fancy stuff that I won't go over. Defined a function that will define a tag. And then use that tag function to define all the HTML tags. And so then you can use those tags to build, one more piece. So in HTTP, this is the HTTP namespace I switched to. This function builds an HTTP response. So here is, this is, I'll move this over. So that is, you can see a little snippet of HTML there. Yeah.
I wonder if you can represent some types with your data type.
Not yet, but I certainly intend to do that with all kinds of neat features. Okay, so this not found is a message ready to be sent to the socket that has a little bit of HTML in it. But we need to write it to the socket. So yet more code, which I will paste over here. Once I grab it. So I define another protocol that is web response. How many of you are closure programmers? Just a few. So you know that your protocol functions cannot have a default function? Well, I can, dang it. Every time a closure program sees this, they're like, oh, that's a nice idea. So it tries to dispatch, this protocol function tries to dispatch on this first argument. If there's not a implementation defined for that data type, then it calls this. And so it's going to print an error out to the standard error and then just abort. But we don't want that. So I extend the core type of string to just write the string to the socket. And then there's a core vector and a core list, which I also extend to. And that empty HTML element also got extended to this so that it knows how to send itself or get sent to a socket with the appropriate HTML boilerplate. And then HTML element also. And so it calls itself recursively to handle all the elements contained in any HTML element. Okay, and so now, with all of that stuff, we'll take this out and just always return not found to the socket. Compile that, and we'll see if it works. And it's working, or it's waiting anyway. So let's, dang it, what happened? Oh, Firefox. So that spit out the HTML. Okay. Got about 20 minutes left. So I am going to paste in the rest of this, dang it. The rest of this function. Oh, first of all, I need a couple more namespaces. So there's a system namespace just to help you with system calls, working with files and the like. And there is a file IO to do file IO stuff. So we're going to take advantage of those namespaces and go grab. So in the file IO namespace, there is, well, let me move this over first. In the file IO namespace, there's the input file type. So we're going to extend it so that it will be able to send itself over a socket. So it opens the file, or the file has already been opened, and it just iterates through recursively, or not recursively, but calling itself send response over and over again. It reads a buffer out of the file, shoots it off to the socket. Okay, I'll come back to this here in a second. We're all saved. Let's see if this works. We're waiting, and now, hey, it worked. This is just a simple file browser application. So if you hit a file, then you get the contents of the file. If you hit a directory, then you can navigate the directory tree. You can see how it stores dependencies of all the stuff. So here's the TCP on the master branch. There's this TCP code. Okay, let's go look at the code that does this. See you down here at handle connection. So there are futures in Toccata. That's how you do the multi-threading stuff. You call the future and you give it an anonymous function, or not anonymous, but you give it a function, and that gets put onto a queue. There's a set of worker threads that read off that queue and execute those functions. If any of those functions block for any reason, basically they're waiting on a promise or reading from a socket, that worker thread halts, but before it halts, it starts up another worker thread to replace it. And then when it unblocks, it just finishes the function and then goes away. So there's always a fixed number of worker threads that are sitting there spinning, executing the futures. So there is multi-threading in Toccata. In Clojure, the for expression only works with sequences, so basically list comprehension. In Toccata, the for expression is generic monad comprehension. For any data type that has implemented the flat map function, you can use it in a for expression. So in this case, we call parse HTTP, just like we did previously, and it returns a maybe value. So this is a monad comprehension inside the maybe value. So if any of these expressions return false, then the value of the for expression is false. But if they return true, or a maybe value, the value that's inside the maybe value gets extracted and assigned to the symbol. So this request symbol gets assigned to the request that was parsed. :path is used to extract, and this is another point. I don't like keyword arguments or keyword values anymore. In Clojure, they're very important. A lot of people use them. I decided they're ugly because I think there are better ways to do things. But I haven't quite eliminated them totally yet. So, so this tries to get a value that's associated with the path key out of the request. If it's not in there, then this fails and we short circuit. But it gets the path, which is a list of strings. And then it tries to read the directory. It assumes that path points to a directory. And then we'll take a look at that here in a second. But if that call fails, if it's not a directory, then it assumes that it's a file. And so it opens that file for input. And this is some pretty generic Clojure type stuff. And either the HTML generated from the directory or the file input, the input file, either of those, because of the OR, gets assigned to the response data. And then we send that response, we make an HTTP response, send it to the socket, and you're good. If we point to some place that's not a directory or a file, then it returns the not found HTML that we saw before. Any questions on that? Comments and the like? Okay, so let's look at, this is just a function that generates that HTML we saw for a directory. And hopefully by this point, you guys can kind of read through that and have some understanding of what it's doing. Because it's just using the stuff that we've already seen to essentially get down here and generate a chunk of HTML. So that is the talk. Questions, thoughts?
Is there more to the concurrency other than just future?
You have future, you have promises, there's an agent. Are you familiar with Clojure's agents? Okay, there's basically copied Clojure's agents. That's it. That's the building blocks. I might add stuff if it was found useful, but that's what I've needed so far, so that's what there is. Yeah?
How do you deal with integers when compiling to C? Like, are they all big numbers?
Huh. So right now, it's only 64-bit integers. There are no floats. At some point, I will add floats, but I think also what you're asking, every value gets wrapped. It's boxed. And then you just pass boxed values around. So the functions don't pass like C integers directly. They're all boxed.
So you can do eventually you like seamless conversion from a big sum to a big number.
So one of the crazy things in the back of my mind, there's a guy that came up with a scheme for encoding numbers, integers, with run length compression in the bit pattern. And I can't even recall his name right now. So way down on my to-do list is have a number format that is not floats, but that expresses ratios. And each part of the ratio is one of these run length encoded bit patterns that can be of infinite size. And so you just have your number type, which could be of infinite magnitude, but also infinite precision. So pipe dream, I have no idea if I'll get there, but right now it's 64-bit integers, because that's what I needed for the compiler. There's some, yeah.
Do you have markers?
Have what?
Markers.
Macros?
Oh, macros. You know, I intend to put macros in there, and actually that for expression is a macro that I've hard-coded into the compiler. So I do intend to do macros eventually, but as I keep working with stuff, I find that I don't need them. And so macros keeps getting pushed down the to-do list because of other stuff that I need more urgently. But I do intend to do macros at some point. Anything else?
So did you implement all the same persistent data structures from Clojure as well? Or?
Yes.
Oh, wow.
Just ported from Java to C, which, I mean, that sounds impressive, but it really wasn't, because the Java is very much similar to C. And there were some very ugly bugs that I created, which, you know how it goes. So it is basically a port of Clojure's persistent data structures. I want to do, there's been some other research, like a lean HANT. So the basic data structure for persistence in Clojure is the hash array mapped tree. And there's been some research on a lean version of that that's supposed to be much more performant. So at some point, I will change my implementation to a lean version and see if I get a performance boost out of it. So down the road. Anything else? Yes.
Mutable variables?
No, not really. The agent is a piece of global, it can be a global value that you can send functions to mutate the value and then make it available globally. But that is the closest thing to a mutable value that there is. Because dang it, immutability is awesome. It just makes your life so much easier. And anyway, I'm about to rant, so somebody stop me.
What kind of interoperability do you have do you have any kind of interoperability with C or?
It's very ugly.
Yeah.
I have some work to do to make that less ugly, but like the TCP stuff is a pretty good example. So you can write a Toccata function, define a Toccata function whose body is just a chunk of C code. And then you can also, at a top level, like include C header files. And so when it builds the C file that's building, it just slams these strings of text into that file before it gets compiled. And there's things you just have to know at this point just to make things work right, and it's just ugly. So, but it'll be there. Anything? I got one more question. Yeah.
On the your ad namespace, I like that, by the way. Are you going to put in some like authentication capabilities in that, so it's not a public?
I would be glad to accept the pull request at some point. So this is all licensed under the Mozilla public license, and I intend to be very liberal in terms of accepting pull requests. I hope to keep the core extremely small so that there will be very little anybody will want to add to the core. And I intend to keep that very tightly controlled, but yet be liberal in accepting the pull request. And then have, hopefully, most everything else, people just do in their libraries. They don't even have to talk to me about anything, not even to distribute their package. They can just get it pulled off GitHub. But yes, authentication, signing, all that stuff. Also, with the GitHub, you don't have to, like in the whole Go debacle with their modules, you can specify the SHA and the branch, and it will be pinned to that particular version of the file in the repo. It will not be, you will not get some random version depending on what they pushed. You will be able to pin it to a SHA. Okay, people are coming in, so if you have any other questions, I'll be around for another couple of hours. Love to talk to you about it, bore you to tears, but there you go. Thank you very much.